connected to a wire. Okay, do you remember that? Okay, that's okay. So
Cause my stomach. So look at
is it a battery?
Let me check that. It is the battery.
Say what? My teacher told me battery.
You were teaching the science class. Wow.
Battery gives you electricity, correct?
Yes.
So that means the car has battery, right? Goodness. Please call the mechanic. Pick out your phone.
No, my phone is dead.
Oh goodness, your phone got no battery.
Yes, it is dead.
What is with this battery? Why can't battery last? Now, in order for us to understand chemical cell, we must understand that chemical cell is made up of two different metals. Now, the two different metals are different in their standard electrode potential, meaning that one metal will have a more negative standard electrode potential compared to the other metal. Now, the metal that has a more negative standard electrode potential will become your negative terminal, whereas your metal with a more positive standard electrode potential will become your positive terminal. Oxidation normally takes place at the anode. Now, because negative terminal is where oxidation takes place in a chemical cell, so your negative terminal will be your anode, whereas your positive terminal will be your cathode. So it's easy to remember because standard electrode potential more negative, so the metal will become a negative terminal. So oxidation happens in the negative terminal, which is your anode. Alright, so more negative terminal, anode, and oxidation. And then whereas for the cathode, the positive terminal, reduction takes place because the standard electrode potential is more positive, so it is called the cathode. Now, after this, we have to look at what we call as the formula to calculate the cell voltage, because this chemical cell consists of two different metals, so we must know how to calculate the cell voltage. Now, the cell voltage is only using the formula of the standard electrode potential of the cathode minus with the standard electrode potential of the anode. Okay, you must remember standard electrode potential, cathode first, then only minus with the anode. So that is the value of the cell voltage in the chemical cell. Now, finally, what you need to know in this topic is you need to know how to write what we call as cell notation. Now, cell notation is to represent Daniell's cell, because in Daniell's cell, as you know, we have salt bridge and porous port. Salt bridge and porous port will separate the two aqueous solution or the two salt solution. So the way we arrange in cell notation is, first we write the electrode in the anode, alright, followed by the aqueous solution in the anode, okay, separated by a single line, then continue with the aqueous solution in the cathode, and finally the metal in the cathode. So you must start with anode first, alright, so electrode, ionic solution, then a line, ionic solution, then electrode. Now that is what we call as standard electrode potential. Okay, after this we're going to have a look at a VR video to further understand, okay, microscopically what really happens in a galvanic cell, okay, especially in Daniell cell. So Daniell cell consists of two metal, which is our zinc and copper, and they are made up of two half cells. So let's further understand using VR.
Introduction to galvanic cell. Galvanic cells have many uses in our day-to-day life. Do you know electric batteries that we use in our day-to-day life are examples of galvanic cells? A galvanic cell uses chemical energy to produce electricity. This is the representation of a copper-zinc galvanic cell prepared in a laboratory. It contains a zinc rod dipped in zinc sulfate solution and a copper rod dipped in copper sulfate solution. The metal rod along with its salt solution constitute an electrode. To complete the external electrical circuit, both the electrodes are connected through a metal wire containing an electrical hub. Zinc, being more reactive than copper, undergoes oxidation to zinc cations and acts as an anode. Hence, zinc along with zinc sulfate solution constitute the oxidation half cell. Copper, being less reactive than zinc, undergoes reduction from copper cations to copper and acts as a cathode. Hence, copper along with the copper sulfate solution constitute the reduction half cell. In this way, electrons flow from the anode to the cathode and current flows from the cathode to the anode. As the reaction proceeds, the mass of the anode decreases and the concentration of cations increases in the oxidation half cell. At the same time, the mass of the cathode increases due to the deposition of copper and the concentration of copper cations decreases in the reduction half cell. This results in the imbalance of ions and electric charge along the two half cells. In order to maintain electrical neutrality, connect both the half cells by a salt bridge containing an inert electrolyte like potassium nitrate. The nitrate ion from the salt bridge moves towards the oxidation half cell to neutralize excess zinc cations. The potassium ion from the salt bridge moves towards the reduction half cell to fill the deficiency of copper cations. In this way, electrical neutrality is maintained inside a galvanic cell. You have completed this activity. Select OK to return to the menu and continue to the next activity. Perform the activity and earn points. You can try multiple times, but points are only awarded if you answer correctly on the first try. Select the beaker containing the required metal salt solutions to prepare a copper-zinc galvanic cell. Right! Correct! Drag the correct metal rods and drop them into the beakers containing their respective metal salt solution. Well done! Well done! The metal rods are ready to make a copper-zinc galvanic cell. Complete the external electrical circuit by connecting a bulb to both metal electrodes. Well done! The external circuit is now complete. The current in the external circuit is decreasing. Insert a suitable device into the galvanic cell to increase the current. Well done! You have increased the current. You have completed this activity. Here is your score. You scored well! Select OK to return to the menu and continue to the next activity. The components of a galvanic cell. Construct a galvanic cell. Follow the instructions to perform the activity and earn points. You can try multiple times, but points are only awarded if you answer correctly on the first try. Select all the components, except for the electrolyte solution, that are not properly arranged in the copper-zinc galvanic cell. Right! Correct! Well done! All the wrong arrangements are selected. Correct the errors in both the half cells by dragging the rods and dropping them into their proper solution. Well done! The metal rods are properly placed. Question 1. What problem would arise when we take a potassium carbonate salt solution inside the salt bridge? Right! Drag and drop the most appropriate salt solution into the salt bridge so that the galvanic cell functions. Right! You have completed this activity. Here is your score. You scored well! Select OK to return to the menu and continue to the next activity. Understand how a galvanic cell functions. Follow the instructions to perform the activity and earn points. You can try multiple times, but points are only awarded if you answer correctly on the first try. The galvanic cell shown here is undergoing discharging. Click on the galvanic cell to understand the function of the salt bridge. Oxidize the metal atom undergoing oxidation. Move it from the crystal lattice of the metal rod to its salt solution in the oxidation half cell. Well done! You have oxidized the zinc atom. Drag the metal cation undergoing reduction towards the cathode and add it to the crystal lattice. Well done! You have oxidized the zinc atom. The electric charge in both half cells are now unbalanced. Drag the proper ions from the salt bridge and drop them into the half cells to balance the charge. Correct! Well done! You have balanced the charge in the reduction half cell. Well done! You have balanced the charge in the oxidation half cell.